Hi, I'm Julian Harty. I'm going to present our short paper on logging practices with mobile analytics, an empirical study on Firebase. A quick thank you to the Shonen Center where many of us met, and Hanan Zhang then joined us and he wrote the software we're presenting in this paper. Logs are vital in software development and software operation, as many practitioners have discovered. In terms of research, there's lots of relevant research on areas including system comprehension using logs in software testing, detecting anomalies, and diagnosing failures, and an interesting paper on the benefits and costs of logging from developers' perspectives. Developers of mobile apps face additional challenges of logging, including the software running on end-user devices and the connectivity not being guaranteed and privacy aspects, etc. From a developer's perspective, to use logging, they need to incorporate the relevant calls into their application code base, and when that app is used, it then triggers the logging APIs, which generates local log messages, and these are stored and viewed locally with tools such as ADB Logcat, a very developer-oriented lifecycle. And some developers use custom libraries such as Timber. The majority, though, use android.util.log. Developers need some sort of solution that's going to work for them in terms of logging end users' usage. And it turns out that they can use additional sources of logs, such as using mobile analytics services to collect and process the information and reduce the heavy lifting. To do this, developers include the library for the relevant SDK for the analytics into their application and call the additional API calls provided by that library. When their software is used, it triggers the analytics APIs. In some cases, it's going to custom versions that the developers have written that wraps the official APIs. Anyway, it generates analytics messages whichever way they do it. These may be logged temporarily on the device before being transmitted to the server when a connection is available, for instance. The server aggregates these logs and processes them and provides the results to developers. The same application is used in different contexts, and it may well include both local and mobile analytics logging, so something to be aware of. Firebase is by far the market leader, which is why we focus our attention in this area, because it's in over 60% of all the Android apps in Google Play, so around 1.5 million or so. It's in over 90% of the top apps and over 70% of the new apps, so its usage is increasing. And this means that the software that you and I use is almost certainly using Firebase for analytics. And it's well worth us understanding the behaviors of Firebase, how developers use it, with the aim of improving the state of the art and the state of the practice. In terms of our research, we used a copy of GitHub called GHTorrent from June 2019. And we filtered and removed clones and forks, etc., and dead projects, and focused on Android apps that included the Firebase Analytics library. We found 107 of these. However, 50 of them just initialized the library and didn't do anything else, so we discounted those from our work, leaving us with 57 target projects. For these, we analyzed every commit from the first to the last. We used git diffs to query GitHub, and we looked at all the changes to the source code, and we loaded these into a program called SourceML and used regular expressions to match either the custom methods, if the developers had written a wrapper API, or the default ones, depending on the application, and stored the results in a database. All our materials is freely available online, including the results and the apps we worked with. The tool we use, SourceML, and the programming language we use, Python, are also freely available. Exodus Privacy is a good place to look at the analysis of Android applications and which libraries they're using. One of the libraries they look at is Firebase Analytics, which happens to be tracker number 49. So visiting this enables us to quickly look through and see which apps are using Firebase. And if they haven't got an app, we can also upload that app and they'll do the analysis for us and tell us what libraries are being used. SourceML didn't work with Kotlin code directly, so we found a workaround, which was to create a soft link with an extension of .java that mapped to the original Kotlin file, and this was enough to enable SourceML to analyze the file sufficiently for the purpose of our research. In terms of our research questions, the first one was looking at the prevalence of the logging code in the code bases. We found that MOBILESoft logging was in 1.35% of all the commits, and it was one line in 1148 lines of source code for the median application that we looked at, with wide amounts of variation. Comparing our results with some related research into local logging, which was co-authored by one of our authors, Wei Ian Shang, we can see some clear differences. The MOBILESoft logging is mentioned in far fewer of the commits than for local logging, so a ratio of roughly 7:1. And in terms of code density, the code for MOBILESoft logging is much sparser than local logging, so a ratio of roughly 1:8. The second research question is looking at what the developers were actually logging. And what we found through our process was that in the order of 51.3% of the log statements were related to domain and business events, or BI, 38.7 related to user interface events, such as user clicking a button, so UI events, and 6.3 related to failures and unexpected situations. These are politely known as WTFs by many people, what the heck's going wrong sort of thing. 2% were specific to an application, such as logging the region for one bus away, and the 1.7% represents the 5 lines that we left unlabeled. In terms of our process, we analyzed 300 randomly selected lines of code in batches of 2 batches of 50 lines per person, where we paired with one of the other authors for each of the 50 lines to compare and contrast until we reached agreement. Comparing our work with the research on local logging, they had 8 categories versus our 4 categories. And we can see that although the names are different, there are a couple of interesting areas that look worth studying. The first is in what they call anomaly detection, which they identify 27.8% of all the commit lines were related to that. And that compares to our 6.3% for failures and or unexpected situations, or WTFs. So we can see that local logging was used far more often for detecting anomalies than MOBILEsoft, roughly a 4:1 ratio. In terms of debugging, it was just under half of all the local logging statements, but none of the ones in MOBILEsoft. This leads us to look in a couple of areas, such as, are there practical constraints currently in MOBILEsoft that means it's not suitable for developers to use for debugging, either in the latency of the feedback time or the latency in applying or revising logging. The second of these could easily be a latency of a week or two by the time an app has been released to the App Store, approved, and finally reached the end user's device. So it may be well worth researching techniques such as infrastructure support for field debugging for the developers to use that's low latency and more suitable. In terms of threats to validity, perhaps we made some mistakes in our categories of the static analysis keyword terms, or in the biases selection of statements or interpretation, but we did our best to minimize these. And we were only able to find 57 open source projects across all of GitHub as of June 2019, versus the 1.5 million applications in Google Play that include Firebase. In terms of future work, a couple of areas that we can think of. One is to involve developers and ask them for their insights in what they use the MOBILEsoft for. And the second is to investigate the context of the logging statements. With that, I'll summarize with a final point, which is that XKCD published a recent cartoon on scientific paper. Ours is on the empirical analysis of open source Android source code. And with that, over to you for questions and answers.